Imagine stepping into a vehicle with no driver, speaking your destination, and then forgetting about traffic forever. The car negotiates roundabouts, merges cleanly, respects cyclists, and glides to the curb like it's reading the city's mind. That's not sci-fi anymore, it's the logical next phase of a technology stack that's evolving faster than most people realize. In this video, we'll unpack how AI is actually driving, why the industry is shifting toward end-to-end learning, the sensor choices that will win, the chips turning cars into rolling data centers, and the safety, regulation, and business model questions that will decide which companies dominate. And stay with me, because in a few minutes, I'll reveal the single metric insiders watch to predict which team will cross the finish line first. Hint, it's not disengagements. By the end, you'll know not just where we're headed, but what to watch next so you're never surprised by the headlines again. In about 60 seconds, I'll explain why maps, yes, boring old maps, might be the make-or-break ingredient of autonomy. 1. Where we are right now. Today, driverless ride-hail is real in multiple U.S. cities. Waymo operates fully autonomous rides, no one in the driver's seat, in Phoenix, San Francisco, and Los Angeles, with official pages now inviting riders in those markets and signaling expansions underway. That means this isn't a lab demo, it's a commercial service that regular people can download and use. And as of August 2025, New York City approved a limited pilot allowing Waymo to run up to 8 vehicles in parts of Manhattan and downtown Brooklyn, with trained safety drivers on board because state law still requires human oversight. It's a cautious step, but symbolically huge. The country's most complex driving environment is now on the roadmap. What this tells us, autonomy has left the prototype phase, but scale depends on policy, weather, infrastructure, and economics. The next wave won't be an overnight switch. It'll be city by city, use case by use case. Coming up, how the brain of the car works and why a quiet architectural shift changed the entire game. 2. The brain, from rules to end-to-end. AI, classic self-driving stacks separate perception to prediction to planning to control. Engineers hand-tuned rules for merges, pedestrians, and unprotected turns. That worked until the long tail of weird edge cases exploded the rulebook. Enter end-to-end learning, a model that ingests raw sensor data and outputs driving decisions directly, trained on millions of real examples. Tesla popularized this shift with FSD version 12, moving away from heaps of handcrafted heuristics and toward a single neural pipeline that learns behaviors like humans do, by watching and imitating at scale. In late 2024 and through 2025, updates extended end-to-end control beyond city streets into highways and parking, signaling a decisive architectural pivot. Why this matters. Generalization. End-to-end networks capture social driving cues, subtle nudges, eye contact equivalents, and timing that are hard to code explicitly. Maintenance. Fewer brittle interfaces between modules equals faster iteration and fewer unintended side effects. Scale. With enough data and compute, performance improves without rewriting rules. Reality check. End-to-end isn't magic. Teams still layer on constraint, safety monitors, and fallback logic. But from here on, expect winner systems to look more like one big brain than 1,000 tiny scripts. In 2 minutes, we'll see why that big brain only works if the senses feeding it are rock solid. 3. The senses. Cameras, radar, and LiDAR. Self-driving isn't just about the brain, it's about seeing the world. Most stacks fuse cameras, texture and color, radar, velocity, weather robustness, and LiDAR, precise depth. Philosophies differ. Some push vision only for cost and scalability, while others insist on redundant modalities to handle glare, rain, and low contrast hazards. Where the puck is going? High-resolution imaging with better low light and HDR, imaging radar that delivers point cloud-like detail at lower cost. Solid-state LiDAR, shrinking size, and power draw. self-supervised multi-sensor fusion that learns what to trust in each condition. In the 2025 to 2028 window, expect leaders to choose hybrid sensor sets tuned to their ODD operational design domain. Urban Robotaxis will likely keep multimodal redundancy, while consumer vehicles may adopt cost-optimized suites with strong software priors. But even perfect senses can get lost unless the car knows where it is and what the road normally looks like. That's where maps come in. 4. The muscles. On-car compute gets supercharged. Under the hood, modern AVS carry data center class compute. 2025's big leap is the arrival of new automotive AI platforms. NVIDIA Drive, AGX Thor developer kits based on Blackwell-class architecture are rolling out, enabling higher fidelity perception, prediction, and generative driving models on the vehicle. Think thousands of tops with safety-certified OS designed for Level 2 plus through Level 4. Qualcomm Snapdragon Ride focuses on scalable ADAS to autonomy, integrating navigation, obstacle detection, and a safety-first architecture that can scale from mass-market driver assistance to automated driving. Mobileye Chauffeur targets eyes-off capability in consumer cars, with a cost-conscious stack and strong mapping tech to broaden geographic reach. Why compute matters? Latency is life or death at 70 miles per hour. Model size is ballooning, especially with end-to-end and world models that simulate future trajectories. Energy efficiency determines range and cooling needs. The upshot: the next generation of AVS will feel smoother and more human-like because the car has more thinking power right where it needs it, on the road. In a moment, I'll show how maps plus memory turn that raw compute into calm, predictable driving. 5. The memory. Maps, priors, and scene understanding. There's a myth that real AI doesn't need maps. In reality, context is king. HD and lightweight semantic maps supply lane geometry, speed norms, and typical traffic flows. Combined with onboard learning, the car builds a situational prior. Where to expect pedestrians at dusk, how traffic pulses after a stadium event, which unprotected lefts are notorious. The winning recipe is shifting to map-light approaches. Use maps as hints, not crutches. The car should handle newly painted lanes, construction, and pop-up closures without panicking. But when maps match the scene, they stabilize the plan and cut compute overhead. Next up, the only safety story that matters, and how teams actually prove safe enough. 6. Safety, how teams prove safe enough. Forget vanity metrics. The serious players build a safety case, a documented argument that the system is acceptably safe for a defined ODD. That case typically stands on 3 legs: massive simulation, billions of synthetic miles where the AI is stress-tested on rare hazards, adversarial cut-ins, and bad weather, scenario replay, and counterfactuals, rerunning tricky real-world events to measure how the system would behave after each model update. On-road validation, carefully staged pilots, geo-fenced rollouts, and progressive expansion as performance stabilizes. Standards like ISO 26262 functional safety and ISO 21448/SOTIF safety of the intended function shape the process, and regulators are getting more sophisticated. NYC's 2025 pilot, for example, requires strict oversight and human supervisors, reflecting a risk-based approach rather than blanket approvals. Key truth: there is no zero risk. The question is whether AVS can achieve lower risk than average human drivers consistently in their ODD and document that improvement transparently. Right after this, I'll share the one metric insiders watch to predict who wins. 7. UX, from Robotaxi rides to your driveway. 2 tracks are unfolding Robotaxis for dense cities. No steering wheel, fleet-managed, perfectly maintained sensors, and controlled ODDS. Consumer cars with eyes-off modes on selected roads. You buy the vehicle and autonomy appears as a software feature that expands over time. Expect human-machine interface, HMI, to mature quickly. Natural language prompts, explanations, I'm slowing because of a cyclist. And comfort profiles, assertive versus chill. When riders understand why the car is doing something, trust skyrockets. But trust isn't just UX. Policy and liability decide how fast this spreads. That's next. 8. Policy. The patchwork gets real. Autonomy is rolling out jurisdiction by jurisdiction. Some cities welcome it, others apply the brakes. The NYC pilot shows how major metros will likely proceed. Small fleets, time-boxed tests, detailed reporting, and human supervisors until the safety case convinces regulators. In parallel, highway-focused eyes-off consumer features will progress where statutes already recognize limited automated driving, often under strict driver readiness or handover rules. Translation for timelines. Policy will gate the speed of deployment more than raw tech capability. Transparency and post-incident process quality will separate the serious players from the hobbyists. If this helped you see the real roadmap for self-driving, beyond the hype, smash that like, hit subscribe, and ring the bell so you don't miss my next deep dive. World models, the AI secret behind human-like driving. I'll break down how cars learn not just to react, but to predict the future like a chess grandmaster. Drop a comment with the city you think will go driverless next, and tell me which part of the stack, sensors, chips, maps, or policy, you think will be the decisive advantage. Drive safe, stay curious, and I'll see you in the next one.